Hey guys, I'm Ovi, and in this video, I'm going to be walking through this code and giving you a demo of this project. The first thing I'd like to say is I highly recommend you reading my article before watching this demo. The article will give you a much deeper understanding of the background behind the project, more in-depth code explanations, background information, etc. So I'd highly recommend you reading that before coming here. But without further ado, let's get into it. The first thing we're going to do is ensure you have your Muse headset and your pedal metrics streaming and connected. So in this code, we're going to do three key things. The first is we're going to get our live EEG data. Second is train our classification model. And finally, input our live data into our classification model to get our predictions and get our results on whether a user has Alzheimer's or not. So the first step is to get our live EEG data. And I forked this steps code from the Muse LSL repository, which there's more information about in the article if you want to check it out. But the key thing here is we're going to be using 4 frequency bands, alpha, beta, theta, and delta, to help us predict Alzheimer's. But how? Well, we have to recognize patterns within this data. Every disease has a specific pattern associated with it. For Alzheimer's, it's decreases in alpha and beta waves and increases in delta and theta waves. And so if our model is able to classify and recognize these increases and decreases in our live EEG data, it will then classify that user as having Alzheimer's. Step 2 is training our classification model. What this first part is doing is extracting features from our EEG data. And so once it has these 4 categories, it'll try and see if it can recognize any of the patterns I mentioned earlier in its categories data. If it does, it'll classify the user as having Alzheimer's. Next, we're going to just load the EEG data from our folders. And from here, we're going to be using the random forest classifier, and I got an accuracy of around 86%. The last and final step is the final prediction. By calling upon previous functions, this last part will identify to see if any of the input data matches the patterns of having Alzheimer's, which are decreases in alpha and beta and increases in delta and theta. If this model recognizes any of those patterns, it'll classify the user as having Alzheimer's. Now, time for the demo. As you can see, the model had around an 85% accuracy and correctly predicted that I don't have Alzheimer's. Thank you guys so much for watching, and I'll see you soon. Bye!